Good morning, students. Welcome to the online lab sessions once again. So, I hope you have enjoyed the previous video, the previous experiment or rather demonstrations, or what we have demonstrated shown to you. The previous, if you remember, just let's do a quick recapitulation. In the previous class, we did about the simple physical change demonstration using hydrated copper sulfate. You remember the blue vitriol salt we took, and we heated that one, removal of the water molecules. We got an white sample, white salt, which is anhydrous copper sulfate, which is white in color, and just after then cooling it again and just adding a drop of water, we are getting back the original copper sulfate, the blue color back. So just emission with the effect of heat, the water is getting out, while leaving the copper sulfate and just getting back. So all these things we have demonstrated, and I hope you have enjoyed the demonstration and the experiments which have been shown to in the previous class. Today again, as promised, we are back with some more experiments regarding with now regarding or rather physical and chemical changes. Today the demonstration will be about chemical changes. So that means we are going to perform some experiments where we are going to see some new products forming. It can be some evolution of gas, or it can be something which is leaving, which from some products or substances which are forming, from which we will be unable to get back the original substance by simple means, physical or simple physical means. All right. So today, let's check it out without, rather, I should say, rather suggest we are going to rather. Okay, now we are going to take up two chemicals. Okay, another two chemicals. One or two chemicals will be taken. One is once again the blue copper sulfate solution, and another chemical is ferrous sulfate solution. So one is copper sulfate solution, and another one is ferrous sulfate solution. And we are going to check it out that how it interacts with ammonium hydroxide solution. So that will be a chemical reaction, and what effects and what are the outcomes. We are going to check those things. So without wasting any more time, let's move on to our experiment section.
We'll move on to let's look out at chemical change. Chemical change, we know that color change will be there, and not only color change, new products are formed. New products are formed. Okay, let's do it. First, I will take, this is once again a blue copper sulfate solution. Previously, we have taken copper sulfate solid. Now we have taken copper sulfate solution. And I'm taking what? Copper sulfate solution in a test tube. And inside that, I am adding a little bit of, what is this? Ammonium hydroxide. I'm adding ammonium hydroxide. As you can see, maybe it's slightly darker because of the chemicals were spilled over it. So, let's check it out. Slightly we added. Previously, if you notice, this solution is a transparent solution. Nothing was there. It's a blue solution, light blue, transparent solution. What you can see over here, can you see the change in the transparency level? Just follow this. Can you see the change in the transparency level? I'd rather go over this. Can you see, identify the blue color? There's a change in transparency. And the solution is no more transparent. It is a turbid solution. It's a turbid solution. That means it's formation of some precipitates. Insoluble substances are forming. And this is basically, with the formation of this insoluble substances, copper hydroxide. Okay, this is copper hydroxide. Hence, with normal only boiling or rather with cooling, I'm not going to get back this original copper sulfate back solution. Hence, this is a chemical change. Okay. Moving on to the next level. Okay. Now we are having another solution. Can you see? It's a ferrous sulfate solution. Now some special features of the ferrous sulfate solution, I'll discuss that one later. But it's basically, it was light green, but somehow with the preparation, with the exposure to the air, the greenish has changed to slightly yellowish. What I'm going to do is, once again, I'm going to add the same chemical. You can see ammonium hydroxide. I'm going to add the same chemical over here. And the same chemical, if I add over here, let's see what happens. Let us see what happens. From a light green or yellowish green solution, can you see there is a dark green? There is a dirty dark green precipitate. Once again, an insoluble substance is there. Okay, once again, an insoluble substance is there. It's in focus. There is a dark green precipitate has formed. There is a dark green, and then when I'm mixing this one, the entire solution is becoming dark green. So if I add more, if I just add a little bit of the NH4OH, this is becoming, once again, as you can see, it's a dirty green. Now the entire solution, as you can see, the entire solution is transferred. I've added more. The entire solution is transformed to dark green, or dirty green precipitate. This dirty green precipitate is actually ferrous hydroxide. So I've taken ferrous sulfate solution. In that I added ammonium hydroxide solution, and I got the insoluble as ferrous hydroxide. So that's all for today's class. So thank you so much. We will have more experiments in our next classes. Thank you.
So you just now have witnessed that how the observations are coming up when two chemicals are mixed, and as I said in the, before the experiment started, the two chemicals that are for copper sulfate solution and ferrous sulfate solution is going to interact with one chemical, ammonium hydroxide we took, and you have seen how the observation comes out with a transparent solution. It was previously, and then later on with a light blue precipitate forming with the first with the copper sulfate solution, and followed by with another where when we moved on to the ammonium hydroxide and ferrous sulfate, it's a dirty green precipitate, the residue forming, dirty green precipitate forming, dirty green, right? Okay, dirty green. So if we move on to our definitely one thing which comes to our mind is how the reaction proceeds and what's the reactions involved with this particular experiment.